Alright guys, today we're going to look at the basic kinds of elements. Metals, nonmetals, and metalloids. What makes them different from each other, okay? So this is real simple. You've probably already dealt with this in physical science again, but still kind of want to go through this simple stuff here, right? Alright, what makes a metal a metal? What makes metals do what they do? And there are a couple of basic characteristics of metals that tell you instantly if it's a metal or not, okay? Number one on the list is metals conduct heat and electricity very well, right? They conduct heat, they conduct electricity very well. And again, you know this because if you look at all the wiring in your house, it's metal, right? Usually copper, metal, but it's still a metal. If you got a stove, right? Just a regular electric stove. The eye on it is basically iron, and you heat it up, and it heats up and it turns red, and it heats up and warms up because it conducts electricity very well, and it also conducts heat very well. So those are two, that's the first thing is metals conduct heat and electricity extremely well, some better than others. Actually, gold is one of the best conductors of electricity, but you can't have gold wiring because it would cost too much. Okay? Metals are also malleable. That's a big fancy word, but it means something very simple. Metals can be hammered. Think of the word malleable and mallet. You can hammer metal into flat sheets like this piece of copper. It's a big, long, flat sheet of metal, isn't it? Okay. You can take that and you can pound it and you can pound it. And if you've ever seen these shows where they show them working and making stuff with metal, they take it a lot of times, and there's a lot of shows where they use forging, they heat it up, and they pound it, and they shape it, or they can roll. They got a roller thing, it rolls it, it'll shape it, and it'll flatten it out, and it'll expand it, and all that kind of stuff. Metals are malleable. You can turn them into flat sheets, right? Metals are also ductile. Now, ductile means something similar. It's basically, you can take metals and convert them into wire, right? You can take any of that and spin it into a long, thin wire. And this is, again, aluminum wire. But you can see it's real simple. We do it all the time. We use it, obviously, for wiring for a lot of things, for conducting electricity, for being able to tie stuff up. You know, we use it for quite a few things, as a matter of fact. But that's, again, what metals can do. You can turn them into that. Metals are also going to have a very high tensile strength. Now, what does that mean? Well, if I take, again, this piece of wire right here, and I twirl it out, and I wrap a little around my finger, and I pull on it as hard as I can pull, okay? I am not going to break this metal. I don't have enough strength in me, nobody does as far as I know, to break this piece of metal strength, okay? It's thick enough that it won't do it. It's got high tensile strength pulling this way. Now, if I were to hook this up to, say, the back end of two trucks and pull on it, yeah, I could snap it then, but that's a lot of power and a lot of energy. It takes a lot of strength to do that. But it has a very high tensile strength. And again, the thicker it is, the harder it is to rip it, right? Okay, so that's tensile strength. Now, metals are also shiny. Again, you keep thinking about a metal. Metals like aluminum foil. Where is my aluminum foil? Ah, here it is. Now this has been beaten around and messed up, but you can still see it's real shiny. As all metals tend to be real shiny. Okay, they may have a silvery looking, they may have a coppery or a gold looking, or they can be different colors, but they will have this metallic shine to them. This is called luster. Okay? Now, some most common examples, things like this stuff. You may have never seen this. This is potassium. It is a metal. You don't find it in nature because it's too volatile. It's too reactive. That's actually stored in kerosene. I've got some similar to it that's actually stored in mineral oil, so it doesn't react with water because it doesn't like real water. This is zinc. Zinc, we know because we can see a lot of things that have zinc in them. Zinc plated and kind of stuff like that. We use those things quite a bit. This is copper. Copper is soft. That's what you'll find if you dig it up It'll kind of be kind of weird looking like that. And then this guy right here, the only liquid metal at room temperature, mercury. We used to use it specifically like in mercury thermometers, but today we don't really use them in those because if you break one and it gets into you, mercury is actually poisonous. A lot of the older thermostats, they had this little switch, and when the little switch had a vial of mercury, and when you lifted it up to a certain level, when the mercury would move, it would connect the two leads, and then it would allow you to kick on your heat. And when you moved it down, the little slide bar down, it would turn it over and it would cut it off because it wouldn't make the connection between the two leads anymore. We don't use those now because most of our stuff is digital, so you don't even have to worry about that anymore. So those are metals. Now nonmetals, I want you to think of the exact opposite. Everything that a metal was, a nonmetal isn't. Okay? Metals and nonmetals are opposites. Carbon, I want you to think about carbon. Your pencil lead. Now again, I don't know exactly why they call it lead. It's not actually made of lead. It never has been. It's actually something called graphite, which is a carbon, it's called an allotrope, but basically here's what it is. It's basically a bunch of carbons joined together, it's all carbon, and then they're flat like this in sheets, and those sheets are laid on top of each other, and that's where you get the carbon. And you know that carbon in the form of lead is very, very common. We have it all the time. But they're poor conductors of heat and electricity, so they're the opposite. They are brittle. They tend to snap quite easily. Metals don't snap easy. Okay? A lot of the nonmetals are actually gases at room temperature. They're not solids, whereas all metals except for one are solids. You know, mercury's a liquid. Everybody else is a metal is a solid. A lot, I think pretty much over half of the nonmetals are actually gases at room temperature. Okay? So again, everything is basically the opposite. Makes sense. If one's on one thing and one's on the other, they must be opposites, right? Okay. Now, some nonmetals. This is sulfur. You ever heard of sulfur? Better yet, you may have known it. Maybe you've heard it called brimstone. Brimstone is a mineral that if you burn it, it actually smells really nasty. It actually smells like rotten eggs. That's because when it reacts, the sulfur reacts with oxygen, it forms sulfur dioxide, which is the same chemical that rotting eggs produce. Okay. This is phosphorus. I don't have any phosphorus because it's pretty doggone reactive. But it is a reactive nonmetal. You ever seen, again, in fireworks. Fireworks sometimes has phosphorus in it because it creates certain colors of light. That's why they use it as well as other things. Okay? But phosphorus creates a very bright, reactive light when it comes in contact with certain things. Oxygen usually. Now this, everybody loves, I don't know why, but this is carbon in the form of a diamond. And the only difference between graphite and a diamond is how the carbon atoms line up. In graphite, they lay out in flat sheets, one after the other. In diamond, they lay out in a, I think it's a hexagonal pattern, but they create these little cubes inside of cubes inside of cubes, and it's a lattice work that's very strong. That's why carbon in the form of a diamond is so strong. But it's still a non-metal. And then, here's a doggone statement. If I got metals on one side and non-metals on the other side, I got to meet somewhere in the middle, okay? And that leads us to elements called metalloids. Metalloids, if you ever look on your periodic table, and you will, the stair step that starts at boron and goes all the way down, those right there are metalloids, okay? They straddle the line between the metals and the non-metals on the periodic table. They have properties of both metals and non-metals, and that's the reason they call it metalloids. They're kind of metallic, but they're also kind of non-metallic. They straddle that fence between both. Okay? They're more brittle than metals, but less brittle than most non-metal solids. So again, they're kind of half brittle, I guess is the word. Sure, half brittle. But they are also what we call semiconductors. They conduct heat and electricity, okay. Okay. They kind of conduct electricity somewhat. It's not as good as the metal, nowhere near, but it's not as bad as the nonmetals. So they're called semiconductors. Okay. Now, some of them do look shiny. There are some of the metalloids, the one I want to mention just in a minute, definitely has a metallic luster. Silicon. Silicon is a very common metal, metalloid, and it's one of the most useful metalloids. Okay? This is what it looks like. It does have a metallic luster. It's nice and pretty. But it's also pretty brittle, relatively brittle. Okay? It is a semiconductor. This is why it's so important to us, is because we figured out several years ago that we could actually use silicon in computers. And this guy right here, this computer chip, is made out of silicon. It's got metal in it, and it's got the silicon in it as well, and it's a very good semiconductor. And we can actually make computers now the size of your little old phone, right? That can have a lot of computing power, because we can create smaller and smaller microchips, as they call them now, and we can put a lot of information in that chip, and it will conduct the electricity that goes through it, but not overload. Okay? So you can put a lot of stuff in a little area, and it won't overload the whole system. Okay? Now, the other metalloids include boron and germanium, and these are just the main ones: arsenic, antimony, and tellurium. Okay? So these are the most common ones that you may or may not have heard of. Now, it all gets back to this thing right here, this periodic table of elements. Now again, this is what we're going to be focusing most of our time on this semester, is this periodic table and knowing those elements, knowing how they form compounds, and knowing what a metal versus a nonmetal, and you got to have these two. You have to have a metal and a nonmetal as a certain type of compound, or two nonmetals make a different kind of compound, and it actually works out pretty well. Okay? So that's basically stuff for chapter 1. Again, keep watching here for videos occasionally. If you have questions, you have my email address. Please email me, ask me anything, okay? And don't forget to make sure that you check not only that, but also we're going to be having some stuff on Schoology as well, okay? All right, we'll see you next time.